Hi, and welcome to our nomenclature video. To start off this video, I'll be showing you how to write a simple ionic formula. To write a simple ionic formula, the first thing that you need to do is you need to gather a metal, which would, in this case, would be sodium. So that would be Na. And you need to gather a nonmetal. So that would be chlorine, and that is Cl. So to write our simple ionic formula, we need to first consider the charges. So sodium is +1 and chlorine is -1. Now if the chlorine or the sodium happened to be a 2 or any other number, it would crisscross and it would go to the other side, meaning that it would be Na2Cl if the chlorine had a charge of -2, or it would be NaCl2 if the sodium had a charge of 2. But in this case, it cancels out because they're both 1, and to write it out, all we need to do is do NaCl, because both of our things only have a charge of 1. That is how you write your simple ionic formula.
Alright, so the next type of formula that we're going to be reviewing is the multivalent ionic formula. So for this example, we're going to be using iron, which has a charge of +2 and +3. This is our multivalent metal. And then we're also going to be using oxygen, which has a charge of -2. Now, for multivalent metals, we have to decide which charge we're going to be using for the formula. So for the first example, we're going to be using the +2, and so in that case it would just be iron +2 and oxygen -2, and since these both have a charge of 2, they would cancel out, giving us the formula of iron oxide. However, if we were to use the charge of +3 for iron, that would change the fact that the two elements, the charges for both elements would not cancel out each other. So by using crisscross method, we would go back to having iron 2 and oxygen 3. Okay, next we're going to be looking at writing simple polyatomic ionic formulas. So for this, we're going to be using the elements sodium, which has a charge of +1, and hydroxide, which has a charge of -1. So in this example, the hydroxide here is going to be our polyatomic ion, and since both of these have a charge of +1 and -1, we're just going to crisscross them and keep their charges since they're only +1 and -1. So in the end we would have NaOH to give us sodium hydroxide.
So now I will be teaching you how to write a multivalent polyatomic ion. So to write our multivalent polyatomic ion, we first need our multivalent metal, which we will be using titanium, which has 2 charges. It has a charge of +4 and a charge of +3. And for our polyatomic, we will be using sulfate, which has a charge of -2. I'll be using both +4 and +3 to show you what the chemical equation looks like for both. So our first one, we will be using titanium +4 and sulfate -2. And to write this, you put both of the charges in their opposite places. So we'll end up with titanium 2 and sulfate 4. Now we can't just leave it like this, because then it would make our oxygen 16, because right now it is only showing that the 4 is attached to the oxygen. So in order to make it attached to all of it, to make it attached to the sulfate, we need to put brackets around sulfate so that the 4 goes to all of the sulfur and oxygen. So 4 can be divisible by 2, so we need to simplify our equation here. So we just simplify it by dividing 4 by 2 and we end up with titanium sulfate 2 as our final product for that one. Now I will be using titanium plus 3 and sulfate, again, -2. Same thing, except we don't need to simplify this time. We will be switching the charges. So we'll end up with titanium 2 bracket sulfate 3. And that is how you write your multivalent polyatomic ion formula. Now I will be showing you how to name your simple ionic formula. Naming is a lot simpler than writing because we don't actually have to write the charges unless it is a multivalent metal. So we'll take our metal and our nonmetal. So this time, again, we will be using sodium and chlorine. And it's very simple. Again, all we need to do is put these two together and make it sodium chloride to make it one substance. Because if it was, so you can't have it sodium chlorine because that makes it two separate elements. We can't obviously do that, and we want one element, one compound. So we add the "ide" at the end so that it makes it one.
Alright, so now we are going to be naming multivalent ionic compounds. So for this example, we're going to be using this formula of iron and oxygen, or since iron is a multivalent metal, it could also be iron 2 and oxygen 3. Now, when it comes to naming multivalent metals, you need to use a Roman numeral in order to represent what charge of that multivalent metal we're going to be using. And so we're just going to write it out as, if you're going to use this one first, which has the iron charge of +2, we're going to be writing it out as iron, and then since it has a charge of +2, we're going to put the Roman numeral of 2. And then to finish it off like the simple ionic compounds, we're just going to end it off with oxide. And then if we're going to be using this one, since this type of iron has a charge of +3, we are now going to write it out as iron 3 instead of 2. And then it's just going to end the same way with oxide as well. Alright, for our next example, we're going to be writing simple polyatomic ionic formula. And so these ones are actually really easy to do. So let's say if you had the example of sodium and hydroxide as your formula to start off with, you're actually just going to use the exact same names for the elements, and so you're just going to end up with sodium, and unlike the regular ionic formula, we're just going to keep the hydroxide name.
So for naming our multivalent polyatomic ion, we will be using our multivalent metal, which will be iron, which has a charge of +3 and +2. And we will be using our polyatomic ion, which is nitrate, which is simply NO3 with a charge of -1. Like before, I will be using both charges +2 and +3 to show you how it is named. So naming is a lot easier than writing, of course. So we will be writing out the name, iron, and nitrate. So the charge is always listed in the name. So let's take iron +3 for example. In an equation, it is always written like this in Roman numerals. It would simply just be that. 3. This is 3. And that was how you would write 3. That would be written right in between these two to create iron 3 nitrate. And that would give you what you need to complete the equation and how you would write it so that it would be correct. And for our second one, we will be doing the same thing, iron, but instead of 3, we will be using 2 to list that it's the +2 charge being used and not the 3. Putting nitrate at the end to create iron 2 nitrate.
This is Parker.
This has been Walker, and this was our writing and naming chemical formulas.